ever looked at the nutrition label on a snack and wondered what percentage of it is actually sugar? Well, the answer to find that is percent composition in chemistry. It tells us how much of each element is in a compound. So let's learn about that. So to understand what percent composition does, we first need to understand that percent composition is used for compounds. And so a compound is a substance that is formed when two or more elements bond chemically together. Compounds have distinct properties from those of individual elements. So as an example here, we have H2O or water, which is a compound made of hydrogen and oxygen elements. As we can see here, we have two hydrogen atoms and one oxygen atom making up this water compound. So now that we know that it works on compounds, let's understand what percent composition is. It tells us what percent of the total mass comes from each element. It is also known as percent by mass. And so now here you can see there is a formula for percent composition, but I'm not going to give it to you. We're going to figure it out with the first sentence that we have here, which is percent composition tells us what percent of the total mass comes from each element. So when we look at the statement, the first half of this, what percent of the total mass, this part here, this tells us how when we see the word of, we know that it's this is what percent of the total mass. So we know that the total mass is obviously going to be in the denominator. So let's first draw a fraction here. And so the thing that we have realized here first is that we have molar mass. So I'm just going to say molar mass is at the bottom because from the definition itself, we're trying to find what percent of each element makes up the total mass. So obviously we are dividing the total mass by the, well, it makes sense to multiply it by the n here, which I'm writing is denoting the number of atoms that we have in that compound, and then times the atomic mass of the element. So that is what our numerator shows. And then we know this is percent composition, so we obviously have to multiply this by 100 to get our percent value. So that is a formula for percent composition. Now let's look at an example. Our first example is NaCl, or sodium chloride, also known as table salt. So to do this first, we need to find the atomic mass of each element that we are given in the compound. So first let's go with sodium, or Na. So as you can see here, we only have one Na and we only have one chlorine. So we don't need to multiply it by any n value, and we can assume there's one atom of each element in the compound. So, and for this, I would tell you to open your own periodic table at the side for reference, because to find the atomic mass of each element, we have to reference the periodic table. And so we know that the atomic mass of sodium is 22.99 grams per mole. So let's do that, 22.99 grams per mole, right? And for chlorine, we know that the atomic mass is 35.45 grams per mole. So 35.45 grams per mole. Now, to find the total molar mass, what we need to do, let me just draw the whole thing here that we need. So molar mass, we just add these two values up to find the total molar mass of the compound. And when we add these two together, we get 58.44 grams per mole. So when we add these up together, we get 58.44 grams per mole. So here we can say that our molar mass is 58.44, right? And now at the top, since we want to find what percentage of each element makes up the total mass, let's start with our sodium, or Na. So for our N, this is just going to be 1 because we know we only have one atom of sodium in the compound. And then times the atomic mass, which we already have here, is 22.99. So when we solve this out, we get 39.3%. So, wait one second. I'm just going to say 39.3% is sodium, Na. Now, there are two ways to find what percent of chlorine is there in the compound, and I'm going to show you both ways. So the first one is just assuming that we have 100% of this compound and then subtracting 100 minus 39.3, which gives us 60.7% of chlorine. So I'm just going to do it this way because it's definitely easier to find. Just subtracting by 100 and getting whatever's left over is chlorine. But you could still go through this whole process again where we do 1 times then the atomic mass of chlorine, which is 35.45 grams per mole, over the molar mass times 100. But this is definitely easier and quicker. So now let's go to our next example. Our next example here is Fe2O3, which is iron 3 oxide. So to find the molar mass, not molar mass, the percent composition of this, we can definitely see it's going to be a little different because, let's see. So let's start with Fe. We're going to find our atomic mass of Fe. So as you can see, there's a subscript of 2 at the bottom of iron, Fe. So we're going to multiply that 2 times the atomic mass of iron, which is 55.85 grams per mole. So 55.85 grams per mole. And then let's do oxygen next. So oxygen would just be 3 times 16, which is the atomic mass of oxygen. And so, okay, I forgot to say, okay, this Fe, when we multiply it out, we get 111.7. So 111.7 grams per mole. And then for oxygen, when we do 3 times 16, which we get 48 grams per mole. Now, to find the molar mass, obviously, we add these two together, right? And so when we add it, we get 159.7. So 159.7 grams per mole. That's our total molar mass right there, okay? Now, let's plug this into the formula, right? So when we do that, we already know our molar mass is 159.7, right? And let's put our times 100 because we know we're going to do that regardless. Now, let's start by doing Fe, or iron, because it has smaller subscript, so it'll be easier. So now there are 2 ways you could write this out. You could either go, okay, based on the formula, you could do 2 times 55.85 because 2 is our n value, denoting how many atoms of iron we have in the compound. Or since we already found this at the top here, we multiplied it out and we got 111.7, we can just do that. So I'm just going to do 111.7, right? Because it's the same thing. You could, if you want to get more comfortable with the topic, you can start off by doing 2 times 55.85, but we've already found it, so we can do it this way. And so when we calculate this out, we get 69.9%. So we know that we have 69.9% Fe. And now for the oxygen, we can, just like I said before, we can subtract by 100 and we get 30.1% of oxygen in this compound. So this is the end of the video here. I hope you learned something new and enjoyed learning it. And if you did, don't forget to like, share, and subscribe. And always remember to stay curious and keep learning. Thanks for watching.